Hello. Now then, the next part that we are going to discuss is number of atoms in unit cells. We are going to discuss three types of cubic unit cell: primitive, face-centered and body-centered cubic unit cell. In the primitive cubic unit cell, the 8 constituent particles are present at the 8 corners of the cube. Now, each of the corner particle is shared amongst 8 different or 8 neighboring. In all, it is shared between 8 cubic unit cell. So, it contributes 1/8 of its part to each of the cubic unit cell. So, this spherical particle contributes 1/8, this contributes 1/8, this 1/8, this 1/8. So, in all, there are 8 particles and each of which contributes 1/8 part. So, in all, the number of atoms at the corners, effectively it turns out to be 8 into 1/8, that is 1. So, effectively there is 1 particle at the corner. There are no particles in the face of the cube. There are no particles at the body center. So, number of atoms in faces, number of atoms at body center is 0 and 0. So, the total number of atoms is 1, which is from the corner of the particle, corner of the cubic cell. The next type of cubic unit cell is body-centered cubic unit cell. In the body-centered cubic unit cell, there are 8 particles at the 8 corner of the cubic unit cell, and there is 1 particle at the body center. So, effectively, number of atoms at the corner would be 8 into 1/8, that is 1 particle. Number of atoms in the faces is 0. Number of atoms at body center is 1. Now, the particle in the body center is contributing completely to this cubic unit cell. It is not shared with other cubic unit cell. So, completely it is present in this cubic unit cell. Hence, we take the number of atoms at the body center as 1 whole. Total number of atoms turns out to be 1 and 1, 2. Next, face-centered cubic unit cell or cubic close-packed unit cell. Now, in this type of unit cell, there are 8 particles present at the 8 corners, and there are 6 particles present at the center of 6 faces. The corner particles contribute, as we know, only 1/8 to the unit cell, but the face-centered particles, they are shared between 2 unit cells. So, each of the face-centered particle contributes only half to the unit cell. So, number of atoms at the corner effectively is 8 into 1/8, that is 1. Number of atoms in the faces, every particle contributes half. There are 6 such particles. So, effectively there are 6 into half, that is 3 particles. Number of atoms at the body center is 0. Total number of atoms is 1 plus 3, 4. So, number of atoms in primitive cubic unit cell is 1. Body-centered cubic unit cell is 2. Face-centered or cubic close-packed CCP unit cell is 4. Now, there are questions asked based on these topics, and these questions are usually deriving the formula of the compound. So, based on this topic, the questions asked are deriving the formula of the compound. First question is: a crystal is formed by 2 elements X and Y in cubic structure. X atoms are at the corners of the cube, while Y atoms are at the face center. The formula of the compound would be dash. So, this is a basic explanation to this problem. Number of X atoms. Now, X atoms, as we know, are present at the corners of the cube. The particles which are present at the corner of the cube contribute 1/8 to the cube. There are 8 such corners, so 1/8 into 8 would be 1. Number of Y atoms. Y atoms are present at the face center. So, number of Y atoms at the face center particles contribute half to the unit cell. There are 6 such faces, so 6 such particles, so half into 6 would be 3. So, formula of the compound would be x is 1 and y is 3. So the atomic ratio is 1:3. You have to take the simplest ratio while deriving the formula. So x is 1, y is 3. The formula is xy3. The correct answer is D, xy3. The next question is, if there are three elements x, y and z which crystallize in CCP lattice with x atoms at the corners, y atoms at the cube center and z atoms at the edges, the formula of the compound would be the number of x atoms are present at the corner of the cube. They are contributing 1/8. Each particle is contributing 1/8, so there are 8 such particles, so the total number of x atoms is 1. Number of y atoms are present in the center of the cube. At the center of the cube, central particle, one such particle, it contributes whole to the cube. The number of particles is 1. Number of z atoms are present at the edges of the cube. Now each edge particle is shared amongst 4 cubes. So one particle will contribute only 1/4 of its part to the cube. So there are 12 edges in a cube. So 1/4 into 12 would correspond to 3. So formula of the compound would be the simplest ratio of x, y and z. X is 1, number of y atoms is 1, number of z atoms is 3. So 1:1:3 is the ratio. The formula would be x1, y1, z3 or x, y, z3. So C is the correct answer.